The ground is shaking, not just on one continent, but across the planet. Moments before several major quakes, Earth's magnetic field registered brief, unexplained distortions, all occurring during the same window that 3I/Atlas passed near our orbit. Coincidence? Or the first sign of a hidden interaction between our planet and something not entirely natural? When scientists noticed this pattern, the data was quietly archived. No press releases, no explanations. And yet, the numbers don't lie. Every close approach of 3I/Atlas leaves behind a subtle pulse in Earth's geomagnetic field, like an invisible fingerprint. If this interstellar visitor can resonate with the sun's plasma, could it also awaken something deep beneath us? Because whatever is happening, NASA isn't talking, and silence in this case might be the loudest warning of all. July 2025. Astronomers spotted 3I/Atlas entering the solar system at a velocity that defied conventional comet behavior. Most long-period comets follow predictable parabolic paths, shaped by gravitational forces dating back billions of years. 3I/Atlas did not. Its trajectory curved in ways that orbital mechanics couldn't fully explain. Dr. Raymond Casper at the Minor Planet Center ran the initial calculations 3 times, each yielding the same unsettling result. The object was adjusting its course. Not dramatically, just enough to suggest something beyond simple gravitational influence was at work. The changes were subtle, measured in fractions of a degree, but they happened at intervals that appeared deliberate. Every 4.2 days, a slight deviation. Every time moving the object closer to an optimal path through the inner solar system. By August, multiple observatories had confirmed Casper's findings. The European Space Agency's Near-Earth Object Coordination Center flagged the anomalies in an internal memo that never reached public channels. 3I/Atlas wasn't behaving like Oumuamua, the first confirmed interstellar visitor that tumbled chaotically through space. This object maintained a stable rotation, its movements precise, almost engineered. Dr. Yuki Nakamura at Japan's National Astronomical Observatory described it in a classified briefing as disturbingly intentional. The word spread quietly through the astronomical community. Something was guiding 3I/Atlas, whether through natural forces not yet understood or something else entirely. September 18th marked the first close approach to Earth's orbital path. 3I/Atlas passed within 0.7 astronomical units, roughly 105 million kilometers. Not close by cosmic standards, but near enough for Earth-based instruments to capture detailed observations. What they found raised questions nobody wanted to ask publicly. The object's electromagnetic signature was wrong. Comets typically display weak magnetic fields, remnants of the solar-wind interaction with their icy surfaces. 3I/Atlas radiated a structured magnetic field organized in layers that pulsed in sync with its rotation. Dr. Helena Vasquez at the Institute of Space Sciences in Barcelona recorded the data and sent it to colleagues with a single subject line: "This shouldn't exist." Then came September 21st. A magnitude 6.8 earthquake struck off the coast of Japan at 1423 UTC. Powerful, but not unprecedented. What caught attention was the timing. Exactly 47 minutes earlier, ground-based magnetometers across the Pacific Rim had detected a sharp distortion in Earth's magnetic field. The anomaly lasted 9 seconds, a brief spike in magnetic flux density centered along the same latitude where the earthquake would rupture. Dr. Kenji Yoshida, a geophysicist at Tokyo University, noticed the correlation while reviewing seismic precursor data. He pulled magnetometer logs from stations in Taiwan, the Philippines, and eastern Russia. All showed the same pattern: a pulse, then silence, then the quake. Yoshida reported the finding to Japan's meteorological agency, expecting dismissal. Instead, he received a call from Dr. Linda Hartwell at the U.S. Geological Survey. Hartwell had been tracking similar anomalies. On September 19th, a magnitude 7.1 earthquake hit Chile's central coast. 2 hours before the main shock, magnetometers in Argentina and southern Chile recorded identical magnetic distortions. Hartwell had initially attributed it to pre-seismic electromagnetic phenomena, known but poorly understood signals that sometimes precede large earthquakes. But when Yoshida shared his data, the timeline became impossible to ignore. Both magnetic anomalies occurred while 3I/Atlas was at its closest point to Earth's orbital plane. You're probably thinking this proves nothing. Earthquakes happen constantly. Earth's magnetic field fluctuates for countless reasons, from solar wind pressure to ionospheric currents. Correlation doesn't equal causation. That's exactly what the initial response concluded. Dr. Hartwell's preliminary report to USGS headquarters recommended further monitoring but stopped short of suggesting any connection between the comet and seismic activity. The data was filed, no alerts were issued. The scientific community moved on. Except Dr. Marcus Chen didn't. Chen, a plasma physicist at MIT, had been studying 3I/Atlas's interaction with the solar wind. He obtained copies of the magnetometer data from Yoshida and Hartwell and overlaid them with solar weather observations from NOAA's Space Weather Prediction Center. What emerged was a pattern hidden in plain sight. Every time 3I/Atlas crossed through a region where Earth's magnetic field lines connected to the sun's, a brief but measurable distortion rippled through the magnetosphere. The distortions weren't caused by solar activity. They preceded solar events. As if 3I/Atlas was acting as a trigger, a catalyst that destabilized the delicate electromagnetic balance between Earth and Sun. Chen presented his findings at a closed-door symposium in Geneva on October 12th. The audience included representatives from NASA, ESA, and several national space agencies. His conclusion was carefully worded, but unmistakable. 3I/Atlas was generating a magnetic wake, a trailing field that interacted with Earth's magnetosphere in ways that could, theoretically, induce stress in the planet's crust. The mechanism wasn't direct. It worked through resonance, amplifying existing tectonic tensions at specific frequencies. The symposium minutes were classified. Chen's research was not published.
October 15th. A magnitude 6.4 earthquake struck northern Turkey at 0317 UTC. The epicenter lay beneath the North Anatolian Fault, a region notorious for seismic activity. Standard tectonic explanation. Except Dr. Elena Petrov at the Russian Academy of Sciences noticed something in the pre-event data. Her magnetometer array, stretching from the Black Sea to the Caspian, had recorded a synchronized pulse 18 minutes before the quake. Not the usual electromagnetic noise associated with crustal stress. This was clean, organized, a wave pattern moving from east to west at precisely 47 kHz. Petrov had seen that frequency before, buried in the data Chen had presented in Geneva. It was the resonant frequency of 3I/Atlas's magnetic field. She contacted Dr. Hartwell immediately. Together, they began pulling seismic and magnetometer data from every major earthquake since 3I/Atlas entered the inner solar system. The pattern was undeniable. 7 significant earthquakes, magnitude 6.0 or higher, had occurred during the comet's approach phase. All 7 were preceded by brief magnetic anomalies at or near 47 kHz. The time lag between magnetic pulse and seismic rupture varied from 14 minutes to 3 hours, but the sequence never changed. Pulse first, earthquake second. Petrov ran statistical analysis. The probability of this correlation occurring by chance was less than 0.3%. Something was connecting 3I Augea Atlas to seismic events, and the mechanism was electromagnetic. By late October, 3I Augea Atlas had begun its final approach to perihelion. The object would pass closest to the Sun on October 29th, the same moment it would align with Earth and the Sun in superior conjunction. For astronomers, this geometry meant temporary loss of observation. The Sun's glare would block direct viewing for nearly 2 weeks. But for geophysicists monitoring the magnetic anomalies, the alignment raised a different concern. If 3I Augea Atlas was indeed interacting with Earth's magnetosphere through solar plasma streams, the conjunction would create the strongest possible coupling. The Sun, 3I Augea Atlas, and Earth would form a direct electromagnetic circuit. Dr. Hartwell issued a quiet advisory to seismic monitoring networks worldwide. No public announcement, no media briefing, just a request for heightened vigilance during the conjunction window. The response came faster than anyone expected. On October 28th, one day before perihelion, a magnitude 7.3 earthquake struck off the coast of Indonesia at 1942 UTC. The magnetometer network across Southeast Asia had recorded the now familiar pulse 31 minutes before the main shock. This time, the signal was stronger. Dr. Yoshida in Tokyo measured magnetic flux variations 3 times higher than previous events. The pattern had evolved. As 3I Augea Atlas drew closer to the Sun, its electromagnetic influence was amplifying. What most people don't realize is that Earth's magnetic field isn't static. It's a dynamic system, constantly responding to solar wind pressure and internal dynamo fluctuations. The field lines stretch from pole to pole, but they also extend far into space, forming the magnetosphere that shields the planet from harmful radiation. These field lines connect to the Sun through a process called magnetic reconnection, creating invisible highways for charged particles. Dr. Chen's theory proposed that 3I Augea Atlas was traveling along these highways, its own magnetic field interacting with Earth's in a way that induced resonance deep within the planet's interior. Resonance is a powerful phenomenon. A singer can shatter a glass by matching its natural frequency. A bridge can collapse if wind causes it to vibrate at the right rhythm. Could a comet, carrying a structured magnetic field and moving through solar plasma, cause the Earth's crust to resonate at frequencies that trigger seismic release? The physics was speculative, but the data kept mounting. On October 29th, as 3I Augea Atlas disappeared behind the Sun, seismic activity spiked globally. Nothing catastrophic, no magnitude 8 or 9 events, but a cluster of moderate quakes, magnitude 5 to 6, erupted across the Pacific Ring of Fire within a 12-hour window. Chile, Japan, Indonesia, the Philippines, all reporting seismic swarms during the exact period when 3I Augea Atlas reached perihelion. Ancient civilizations might have called this an omen. The Egyptians recorded stars with long tails in the pyramid texts, associating them with upheaval and change. Chinese astronomers during the Han Dynasty documented broom stars that appeared before earthquakes and floods. Sumerian tablets for Mesopotamia describe celestial visitors bringing trembling earth. Modern science dismissed these as superstition, pattern seeking in random events. But what if the ancients were observing a real phenomenon that only became quantifiable with modern instruments? Dr. Vasquez in Barcelona began researching historical comet sightings and cross-referencing them with geological records. She focused on documented earthquakes that occurred during periods of bright comet visibility. The correlation was weaker than the 3I Augea Atlas data, mostly because ancient records lacked precise timing. But certain events stood out. The earthquake that destroyed the city of Pompeii in 79 CE occurred during a year when Roman historians noted an unusually bright comet. The Lisbon earthquake of 1755, one of the most powerful in European history, happened 6 weeks after astronomers across the continent observed a long-period comet passing near Earth. Coincidence? Possibly, but the pattern suggested something humanity had overlooked for millennia. NASA's official position remained unchanged. 3I Aegea Atlas was an interstellar comet, remarkable for its brightness and unusual trajectory, but fundamentally a natural object governed by physics. Any correlation with seismic activity was statistically insignificant and likely the result of confirmation bias. The agency's public affairs office declined multiple requests for comment on the magnetometer data. Internally, however, conversations were different. A working group had been formed, bringing together heliophysics experts, seismologists, and planetary defense specialists. Their mandate was classified, but the core question was simple. If 3I Aegea Atlas could influence Earth's magnetosphere, what else could it affect?
November 3rd, 3I Atlas emerged from behind the Sun, and the first images confirmed what Dr. Chen had feared. The object was brighter, not fading as it should while moving away from perihelion, but intensifying. More troubling was what happened on Earth during the blackout period. Between October 28th and November 2nd, when ground-based telescopes couldn't track the comet, seismologists recorded 43 earthquakes above magnitude 5.0 worldwide. The global average for a 5-day period is typically 12 to 15, nearly triple the expected rate, all occurring while 3I Atlas was hidden behind the Sun's glare, presumably at its moment of strongest electromagnetic coupling with the solar plasma streams. Dr. Petrov's magnetometer network in Russia had continued recording throughout the conjunction. Her data showed something unprecedented. The 47 kHz signal didn't stop, they accelerated. During the peak of conjunction, her instruments detected pulses arriving every 8.4 minutes, a rate far higher than any previous observation. Each pulse was followed, within 20 to 180 minutes, by seismic activity somewhere on the planet. The earthquakes weren't clustered in one region. They spread across fault lines on every continent, as if something was systematically testing the structural weak points of Earth's crust. You might wonder why this wasn't headline news. The answer lies in how scientific institutions handle data that challenges fundamental assumptions. Earthquakes are supposed to be driven by plate tectonics, the slow, grinding collision of continental masses over geological timescales. The idea that an external cosmic object could trigger seismic events through electromagnetic resonance belongs in fringe theory, not peer-reviewed journals. Dr. Hartwell's team at USGS prepared a comprehensive report documenting the correlation between 3I Atlas's position and seismic activity. The report was submitted to the National Science Foundation on November 6th. It was returned 4 days later with a request for additional verification and alternative hypothesis testing. Translation: find another explanation or this isn't getting published. Dr. Chen took a different approach. He contacted Dr. Sarah Okonkwo, a theoretical geophysicist at Cambridge University, who had published controversial papers on electromagnetic earthquake triggering. Okonkwo had been marginalized by the mainstream seismology community for suggesting that external electromagnetic fields could influence fault rupture timing. Chen shared the 3I Atlas data. Okonkwo spent 3 days analyzing it, then called Chen back with results that made both of them reconsider everything they thought they understood about planetary systems. Okonkwo's analysis revealed that the 47 kHz signal wasn't just correlating with earthquakes, it was modulating them. The strength of the magnetic pulse predicted the magnitude of the subsequent quake with 73% accuracy. Stronger pulses preceded larger earthquakes. Weaker pulses preceded smaller tremors. The time delay between pulse and rupture depended on the depth of the fault and local crustal conductivity, variables Okonkwo could model with precision. This wasn't random correlation. It was a measurable cause and effect relationship. 3I Atlas was generating electromagnetic waves that propagated through Earth's magnetosphere, penetrated the crust, and destabilized fault zones already under tectonic stress. The comet wasn't creating earthquakes from nothing. It was acting as a trigger, releasing energy that had been building for years or decades. The implications were staggering. If a single interstellar object could influence seismic activity across an entire planet, what did that mean for planetary stability in general? How many historical earthquakes might have been triggered by cometary passages nobody thought to document? And more urgently, what would happen when 3I Atlas reached its next critical alignment with Earth? Dr. Nakamura in Japan ran the orbital projections. 3I Atlas would make another close approach to Earth's orbital plane on November 18th. Not as close as September, but given the object's increased electromagnetic output post-perihelion, proximity might not matter anymore. The magnetic coupling could be affected across much greater distances now. Nakamura shared his projections with the working group. Their response was to recommend continuous monitoring, but avoid any public statements that might cause unnecessary alarm. The phrase appeared in 3 separate memos. Unnecessary alarm, as if warning people about a potential increase in seismic risk was somehow more dangerous than staying silent. On November 12th, Dr. Vasquez published her historical research in an open-access journal, bypassing traditional peer review. The paper documented 23 major earthquakes throughout recorded history that occurred within 60 days of significant comet apparitions. The correlation was weak for most events, stronger for a handful, and undeniable for 3, including Pompeii and Lisbon. Vasquez's conclusion was carefully worded. She called for renewed investigation into possible electromagnetic linkages between celestial phenomena and terrestrial seismic activity. Within 48 hours, the paper had been downloaded 47,000 times. Within a week, it became the most read article in the journal's history. The public response split predictably. Mainstream media largely ignored it. Science blogs ranged from cautiously interested to openly dismissive. But social media erupted. Hashtags linking 3I Atlas to earthquakes trended across multiple platforms. Conspiracy theories blossomed, some claiming the comet was artificial, others suggesting government weather control experiments. Lost in the noise was the actual science, the careful measurements, the statistical analysis, the physics that suggested something real was happening, even if the mechanism wasn't fully understood. Dr. Chen received a call from NASA headquarters on November 15th. The conversation was brief and pointed. He was asked, not ordered, but asked firmly, to refrain from further public discussion of his research until proper interdisciplinary review could be completed. Chen agreed, then immediately contacted 6 colleagues across 4 countries. If official channels were closing, unofficial ones would have to suffice. They formed a monitoring network, independent of government agencies, funded by university discretionary budgets and private donations. Their mission was simple: track 3I Atlas, monitor Earth's magnetosphere and seismic activity, and document whatever happened next. Because something was happening. The magnetic pulses were still coming, stronger and more frequent with each passing day. And 3I Atlas, now clearly visible in the pre-dawn sky with its brilliant green tail stretching across 15 degrees of arc, was no longer leaving. It had adjusted course again, slowly, deliberately. The new trajectory would keep it in the inner solar system for months, possibly years. Whatever 3I Atlas had awakened in the depths of Earth was just beginning, and the silence from those who should have been warning us was perhaps the most terrifying data point of all.